Hi, third grade. How are you? So last time we spoke, last time we had a video, we were looking at how to calculate concentration, and we're just going to continue that today because there are other methods of calculating concentration too. So let's go. So this is concentration two. So last time we saw that a solution is made of a solute and a solvent. Remember, the solute was usually something solid and the solvent was usually the liquid component. For example, in seawater, water in the ocean, the solute would be salt and then the solvent would be water. Okay? So if we take that solute and divide it by the solvent, we identify the concentration. And we were using the measurement grams per liter. Okay? So today we're going to look at two other ways of measuring concentration, and that's concentration as a percentage and concentration in parts per million. Okay, so let's have a look at percentage. So why do we do percentage concentrations? Okay, there's a process called the Haber process, which is used for making ammonia, which is needed to make fertilizers for plants. Now, the Haber process uses nitrogen from the air, okay? But we don't know, well, we do know we need to calculate how much of the air is nitrogen, so then we can know how much air we can use in our reaction. So we know that nitrogen is 78%, it's the largest component of air. These are the other gases, obviously oxygen is the other famous one, 21%. But it's important that we know that nitrogen is 78%, so we know how much air to use in the reaction. So to calculate a percentage concentration, it's quite a simple equation like last time, but something that's very, very important are the units, okay? So we take our mass of solute and then we divide it by the volume of the solution, okay? Now it's very important that the mass is always in grams and the solution or the volume is always in milliliters. Last week we did it in liters, but this week it needs to be in milliliters. Divide that first. It's very important that grams is first when you divide. Multiply by 100, and that gives you your percentage of the solute, okay? For example, what is the percentage concentration of 30 grams of sugar dissolved in 215 milliliters of water? So 30 divided by 215 is 0.14. 0.14 times 100 is 14%. So there's 14% sugar in this mixture and there's 86% water, okay? So now we're going to look at parts per million, okay? So parts per million is a way of measuring concentration when there's a tiny amount of solute in a very large amount of solvents, okay? So if we would try to make it as a percentage, it'd be a really, really small number like 0.000. And when we do percentages, we don't want to get too small. It could be confusing. So it's easy to use parts per million. So this is common when we want to find soil concentration, because soil, where plants grow, you can have a lot of soil and there might be just a few fragments of minerals like nitrogen and phosphorus that plants need. So we can do it when we're trying to calculate soil quality, or also fluoride in your toothpaste. So fluoride is very important for the health of your teeth. However, too much fluoride will kill you. So we only want a really, really, really small amount of fluoride in our toothpaste. And if you look at your toothpaste right now, all of them will have the amount of fluoride they have in parts per million. So here we can say 1,450 parts per million of fluoride. Now, again, kind of similar, but the units are different. So for parts per million, we take our solute divided by our solvent, but this time we need to have milligrams and liters. This is very, very important. It must be milligrams and liters. Why? Because a milligram is 1 times 10 to the minus 6, okay? So let's look at an example. What is the concentration in parts per million of 2.5 grams of nitrogen in 12 liters of soil? Okay. So our first problem is our grams. We need to convert these into milligrams. So 2.5 times 1,000 is 2,500 milligrams because there's 1,000 milligrams in a gram. So you just multiply it by 1,000, and then 2,500 divided by 12 tells us our answer, 208.33 parts per million. Okay, so you just have the milligrams divided by the liters, and now you tell your parts per million. So your turn. I've got 4 questions here. The top 2 questions are percentage concentrations, and the bottom 2 questions are parts per million questions. Use these equations here. They will help you, okay? The only thing that you need to worry with this, it's not difficult, but just make sure you keep to the units. So for percentage, grams over milliliters multiplied by 100. And for parts per million, milligrams divided by liters. Guys, that is the end of our class today. I'll be online. Let me know if you have any questions, and I look forward to seeing your work. Take care. Have a nice day. Bye-bye.